Good morning, ladies and gentlemen. 2 weeks ago, John kind of sent me an email saying, Deo, perhaps we can summarize everything we're talking about, our business philosophy, our business strategy, and everything that we're doing and all about us in 2 words that to identify us, and that's we are distributed refining architects. I thought that was fantastic because it kind of summarizes the essence of who we are with respect to BioSyn. Okay, now I say with respect to BioSyn because we have a mother company, which I'll not really discuss that today, where we have a much bigger business model. But for the purposes of BioSyn is concentrating on the idea that we build small footprint refineries in proximity to the oil heads or in proximity to the users with almost the same unit cost as if you build, let's say, 20,000 or 50,000 barrels per day. Instead of producing a whole range of products, we make them dedicated refineries for a particular product. So for example, if it is diesel, if we want diesel, we only build a refinery just for the production of diesel. If it is gasoline, it's also gasoline. So we're not gonna, in our architecture, we're not gonna produce, let's say, gasoline and then kerosene or jet fuel, diesel, gas oils, etc., etc. So these are small footprint refineries from 1,000 barrels per day to 10,000 barrels per day, in contrast to the traditional model where they build 25,000, 50,000, even 500,000 barrels per day. And they cost in the range of multi-billion-dollar cost of construction. And so only the moneyed companies, the big boys, can go into that. So much so that our business model kind of democratizes entry to the oil industry or to the oil refining industry. So to describe who we are kind of DRAs, distributed refining architect. What's our vision? Well, our vision really is to kind of lower the cost of entry to the oil refining industry. And so we call that democratizing entry to the petroleum refining industry. And we would like to produce what you call specialty fuels, or sometimes referred to as boutique fuels. And one of our stockholders referred to as wonder fuels, that's land. But the industry refers to them as boutique fuels. But they are not just boutique fuels for no good reason. They're actually ultra clean fuels. They are good for the environment. They are safe to public health. And in the case of gasoline, we're going to be producing them, besides being benzene-free and aromatics-free and so on, we're not going to be producing them with conventional technology like the use of a very dangerous acid like hydrofluoric acid. Now I know that DuPont does alkylation or using sulfuric acid. That's not as bad as the hydrofluoric acid. I'm not just saying that they use DuPont here, but it's not as bad as hydrofluoric acid, but still it's an acid, right? So we're going to be using a non-acid catalyst to produce a benzene-free, aromatics-free, ultra-clean gasoline. More about that in a short while. So that's our vision. And that kind of commoditize these boutique fuels. Because what we have today, the gasoline, the kerosene, the diesel, are essentially based on standards that the industry and the regulators have kind of compromised. So when they say diesel with a distillation range of from this to this, it doesn't mean that other petroleum fractions like in the kerosene range you cannot use them as diesel. I got some kind of an insight on this a long time ago from the US Air Force. Personal. He was a Vietnam veteran and he was telling me they're developing JP4 And what is that? Well, it's a blend of kerosene and naphtha. I said, what's that for? I was very young at that time. And he said, well, during the time of war, we would like to have more access to a variety of feedstocks, and one of them is naphtha. So when you blend naphtha with kerosene and formulate them in a manner that you have all the additives for required in a jet fuel, then they call it JP4. But I also learned later on that in the United States you have a special winter blend of diesel, which is not your, what they call D2, which is your normal diesel. They blend it with a D1, okay? And the D1 is what? It's kerosene. So anyway, to make the story short, you can actually create boutique fuels out of the standards that the industry and the regulators have agreed on, and actually come up with a better fuel. And basically that's one of our specializations. Okay. But what about our vision for Nebraska? If you don't mind, I'll spend a little bit more time on this, okay? Because we are from Nebraska. Well, let me start this way. The Department of Economic Development has some kind of a website material that describes how fantastic Nebraska is. But on top of that, this is how I look at Nebraska. Nebraska is in proximate distance from a source of a very important raw material that can be processed to create high-valued products and stimulate the economy, the local economy in the process, and create a lot of jobs that you can export overseas. I'm referring, for example, to North Dakota. North Dakota produces, right now, North Dakota is it's like a wild west there. They're increasing the production of what they call unconventional oil. Unconventional in the sense that the conventional, when you drill, and you reach a certain formation where basically the hydrocarbon is in the form of either gas or liquids, and they just pump the liquid up. Well, in this case, the unconventional is that they're embedded in rocks, and you have to fracture the rocks to release the oil or the gas. So they call it unconventional. But the nice thing is, there's a lot of that unconventional oil in North Dakota. They call it back-end oil. They also have, in another lower layer, underneath the back end, is 3/4. And when I got a sample, it's a lot better than back-end oil, but they just mix it. The problem is, and again, I warned you I'm getting into some details, but for a reason. Most of the players there are out of states, either from Colorado, Texas, Oklahoma. And so, you cannot blame them if they have this attitude that they see a very thick forest, lots of trees. And then what they do is they just cut the trees, turn them into logs, and export the logs. That's it. But if I were in North Dakotans, I would say, well, why don't you turn the logs into lumber and turn the lumber into furnitures, create more valuable products, and create local jobs in the process. Well, we did visit, Conrad and I and Fred visited North Dakota, talked to some of their people there, and it's almost like they have no idea as how to, add value to crude oil. They're just happy getting the, what do you call it, the royalty or the taxes. And those companies simply drill the oil, transport them out of North Dakota. Well, to be fair, there is right now I don't know what the stage of that, the construction of a refinery. They call it a refinery. Actually, it's just a topping plant. They separate naphtha and kerosene and diesel. Basically, that's it. It's 20,000 barrels per day. But I think right now they're almost like 1 million barrels a day, almost. If they haven't reached 1 million yet, they will, maybe in the next few months. And there's a lot more. Well, our vision is that since North Dakota is nearby, we use that crude oil and refine them in Nebraska. But initially, maybe refine them to ultra-clean fuels, all right? And I will talk more about what really is the meaning of ultra-clean fuels to us. But convert them further into high-value products, petrochemicals, such that we are actually creating a petrochemical industry in this right here, because we have plenty of raw materials just 2 states away. And on top of that, you couple that with hydrocarbon that we can derive from biomass, which can be planted as dedicated energy crops in marginal lands, of which Nebraska and the surrounding states have plenty. And by the way, the technology for deriving hydrocarbons from biomass is there, except that it's commercialized right there in Canada. I'm referring here to Adam is from Canada. Zidane is from Canada. So we can work with them such that we can derive this biohydrocarbon and then couple that with what we can produce from crude oil and come up with a much better product, high in terms of quality but also value, and create lots of jobs and stimulate economy in Nebraska. And if you imagine, if you're a farmer, imagine large tracts of lands that are marginally used or not utilized at all, and you can plant them with, let's say, fast-growing switchgrass and other similar dedicated energy crops, all right? And use that as feedstock to produce your biohydrocarbons. Hydrocarbons meaning hydrogen and carbon, which you can get also from petroleum, natural gas, coal, and from your corn stalks. You know, we have plenty of vegetable oils which can be converted into methyl ester. But the best thing that we're doing now is just to burn it as biodiesel. Blend it with 20%. Blend 20% of that with petroleum diesel and call it a biodiesel. But we can improve that and create more value to the finished product. So the idea is to make Nebraska some kind of a center for petrochemicals and oleochemical industries. Oleo meaning kind of vegetable oils. Petrochemical means a chemical from petroleum, and oleochemicals are chemicals coming from vegetable oils. Okay? So that's our vision for Nebraska, in a nutshell. And hopefully we can get this vision, we can share this with the state authorities, starting with our executive director with the State Energy Office, and we can work from there. But how do we do that? As Ginger said, we're kind of new. It's true, we're very new. So how do we do that? This is like so audacious to make those claims. Well, we do that by leveraging on our, first of all, our distributed refining model. And we will do this in close cooperation and collaboration with essentially our primary vendors. I'm referring to DuPont, Invincis, and Zeton. There will be other contractors, but these are the 3 pillars on the engineering side. And of course, that requires hundreds of millions, if not billions of dollars, depending on the size of the project. So we intend to take advantage of the newly democratized financing environment. We will talk more about that, especially when you hear from Launch, Spencer, Taylor, and from Adam about that. One time I told our directors that we thrive on high standards. We actually encourage regulations that would increase the level of standards with respect to the quality of our fuels and chemicals, and also the method of production. As long as, of course, they are reasonable and implementable. So there are within reasonable limits, of course. So We are in support of regulatory standards for better environmental protection, public health protection, how to improve productivity. That's why when Ginger mentioned about one of the missions of her office is to improve the energy efficiency. That relates to productivity improvement. So we are in support of that. And we are in support of standards that would stimulate the economy. And also, as a matter of fact, and let me just kind of digress a little bit here about that. For every gallon of fuel or petrochemical that we will be producing out of back-end oil, at least half of the value of that replaces the dollars that we use to import crude oil. Right now, every time you buy gasoline, almost half of that, the raw material, come from imported crude oil. So when we use back-end oil or Eagle Ford or Marcellus, that's 100% American source. That would have a very big impact on our balance of trade payments. Okay, so who are these three primary technology vendors? This is like a stool with three legs. It's very stable. Okay, number one is DuPont. I purposely put the generic name. It's liquid phase hydroprocessing technology. Their trade name for that is isothermic. Now I say liquid phase because the conventional use in the industry is what they refer to as gas phase hydroprocessing technology. And hydroprocessing means you use hydrogen in order to traditionally get rid of the sulfur in the oil or in the fuel to meet the regulatory standards. That's very important for us because without that, we cannot do what we say we can do with respect to small footprint refinery. So I thought isothermic, that's very important. But DuPont is basically a process licensor. They give us the invention in the form of what you call basic design, or in the industry we call it Schedule A. You cannot build, however, a refinery out of that. That's just like a drawing, some description of what are the basics and so on. So we need to come up with a what you call a detailed engineering based on DuPont's technology. And then, of course, you have then to construct the refinery based on the detailed engineering design. So who will do that for us? Well, it took me a long time, a lot of travels, a lot of talking to people, a lot of plant visits before I found a company. Not in the United States, but in Canada. That's where Sweden is. Because there are so many companies, they call themselves EPC companies, engineering, procurement, and construction. Let's say they can do, there are so many companies that can do the engineering and the construction. But I have not found one, except in Canada, where they can build a small footprint refinery, or what you call unit processes, at 500 barrels, 1,000 barrels per day. As a matter of fact, their specialization is like pilot plants. Okay? But then they have built, or they're in a position to build a commercial size unit that's actually already our main, main size, which is about 1,000 barrels per day. Now, as I said, I have visited so many fabricators in the United States, and some of them actually scare me. I mean, I don't know if you have done that. There's some of the subcontract. You deal with these big companies, and then these big companies, they look so good, but then at the end of the day, they actually subcontract their work. So I went down to the actual fabricators, I talked to the engineers, I look at their facilities, and some of them scare me. Not all of them, but some. But I was so encouraged when I saw Sweden's facilities. Not only that they know really what they're doing, besides doing the engineering work, then they do the building of what they have engineered. So it's very nice. In the industry, normally what happens is that the engineering firm will do the detailed engineering and then bid out the construction. So in this case, Seaton will do the engineering and the construction. So that's the second leg of the tool. The third is Invincis. Invincis, originally, I got the impression that they're just like another company, like a process automation system supplier, like Rockwell, right? Like Honeywell, like Siemens, and so on. Well, it turned out that they have a lot more software that can actually make my life a lot easier as the one puts it all together. And also, Invincis is one of those who originally kind of fought our much bigger vision and kind of supported us right from the start. And so when I attended their users conference in San Antonio about 3 weeks ago and talked to their top executives and their engineers, I saw that, boy, this is really the company that can make my life easier as what you call the head honcho architect, technology architect. Okay, I would be able to sleep at night, especially with respect to safety and cybersecurity, but also systems that will prevent things like information overload, things like, I'm really scared about, for example, this hacking thing, And so I talked to their security experts, and they convinced me that whatever we build, at least the idea of preventing unnecessary troubles, whether it's man-made or not, at least their systems can reduce that. So those are the three. Those are our three primary technology vendors. Now, of course, don't get me wrong, the whole refinery is not just hydroprocessing, there are so many others. But the suppliers of those other peripheral technologies they come a dime a dozen, and they're very, very simple. And anybody can do them. But these are the three that we really need to make, for us to be able to implement our model. We call them enabling technologies. In kind of dealing with them, coupled with our own proprietary processes and our own technologies, we create certain distinctives that set us apart from the others. In the normal business lingo, they call them unique competitive advantage, value proposition. I'd like to call them distinctives. What are those? Now, remember, we are small and we're just starting. But here are our audacious claims, okay? We have advanced product lines that are environmentally responsible and safe to public with respect to not only the final products, but also in the way that we produce those products. So for example, our diesel would be, in the end, colorless, odorless. They are non-toxic. They almost have similar hydrocarbon composition as your mineral oil that you buy from Walgreens. The purgative. Well, you drink them. You don't die because you drink the mineral oil. That's pure hydrocarbon. Our diesel is almost like that. Okay? Now, but the one very important nuance of this is this. And this is where I'd like the reaction from the experts in the oil industry. A normal processing scheme in the oil refinery is such that they try to maximize the production of gasoline. So besides their normal process of reforming naphtha to increase the octane and then isomerizing what you call the light naphtha into isomerates, what they do is they crack the light and heavy gas oils. They crack that and they come up with what you call olefinic gasoline. It's high octane. And then they blend that with their conventional aromatic-based gasoline. But in the process of cracking those light and heavy gas oils, they produce what you call light cycle oil. Now this light cycle oil is very, very unsaturated. In the industry or in chemistry they call it olefinic. And it's very hard, it's very difficult to burn. So in a diesel engine, pure light cycle oil, it would not, if you use pure light cycle oil, which by the way has more or less the same viscosity as your diesel, your engine won't work. It might start, but it cannot run. What they do is they blend that with your normal diesel. That normal diesel, they call it straight run diesel. And a straight run diesel with about 20% aromatics has about 50 to 55 cetane number, not index, number. Then they blend that with light cycle oil in situ in the refinery. And light cycle oil is about 20, more or less 20 cetane. So you blend that, and in the Philippines, and even here we call that adulteration, fuel adulteration. In the Philippines though, it is a criminal offense legally to adulterate your fuel. But here, they blend that. So sometimes if you have a diesel car like me, sometimes I get this kind of diesel that's, it creates a lot of vibration in my engine. Okay. But in effect, what the oil industry is actually doing is let the public incinerate their waste through your diesel engines. And before they come up with limiting the olefins in the diesel fuel, they blame the engine manufacturers for all the heavy particulate emissions emanating from diesel engines. So I purposely went into some details on this for you to appreciate the fact that since our refinery does not have what you call a fluid catalytic cracker or a cracker that cracks heavy and light gas oils, and therefore we do not have light cycle oil. And so we do not have light cycle oil in our diesel. And that alone will already contribute to a very good emissions profile of our diesel fuel, that alone. The absence of light cycle oil will improve tremendously the quality of a diesel fuel. So that's one of our claim to fame. Our diesel will not contain light cycle oils, among others. So it is good for the environment, it's good for the public. Industry entry democratization. For $30 to $50 million, you can have a refinery. Unlike, conventional refinery, you need at least a few $100 million, so several billion. Then, light crude oil has plenty of naphtha component that is traditionally used as your feedstock for gasoline. But your gasoline has a lower price than your diesel. But in our case, we can use a cheap, increasingly cheaper feedstock in light crude oil and turn that into a full, almost 95% diesel, which is a higher price. I call that a technical arbitrage play. No refinery is currently doing that in the United States. In other words, if they have light crude oil that contains a lot of naphtha, they have to separate the naphtha in order to produce kerosene and diesel. And naphtha, they still have to split that into light and heavy, and the light, they isomerate to increase the octane, the heavy, they reform to increase the octane, blend it. And so in the process, you increase the cost, you increase your carbon footprint, and sell it at a lower price. Whereas in our case, we don't have to go through that, but then our finished product that contains naphtha is still diesel. That's why earlier I made the point of we're creating boutique fuels, but better in terms of quality and performance than your conventional diesel. We have what you call a full service offerings. This is in the context that we actually we have what you call a full service offerings. This is in the context that our business model is such that we build refineries for others. We're going to build one for us as a demo, but basically we have clients, some of you are here, where we're going to build refineries for you. And we have a full service offering. And we call that distributed refining architecture, engineering, procurement, and construction services. Now if you Google EPC, you will get a lot of companies. EPC means engineering, procurement, and construction. Or EPCM, engineering, procurement, and construction management. We added one, which is distributed architecture, refining architecture. And actually also we added some more, which is the capital formation support services, which we'll discuss more. So this is in the overview of our what you call full services, which we call DEPCS, Distributed Refining Architecture, Engineering, Procurement, and Construction Services. Okay, and each of those, the technology architecture, involves engineering, procurement, construction, commissioning, and then the capital formation support services. That is what we have added only about 2 months ago, because of the release of the rules and regulations on the JOBS Act that will enable us to assist and support our clients raise funding in the form of equity and project financing in a legal way, but in a much easier way if we follow, and we will, the regulations, all the regulatory compliance requirements, okay, which we will do through third-party services. Then we have the operations, and as I said, Invincis will play a big role in that, and they have a lot of services that we can use in that area, operations management. In fact, if you Google Invincis, they have actually, a separate division for that, operations management. Risk management and mitigation services. The idea here is, even if our process licensors provide what we call in the industry as process guarantees, all our contractors will provide performance guarantees. There are still other things that need to be covered, other risks, and we have started to negotiate. In fact, Mars is supposed to be here. That company is a multi-billion company, also based in England, where they provide the services as a third party, including insurance, and they play in nuclear power industry, power generation, petrochemicals. They're huge, okay? And when we explained to them our business model, initially they were kind of skeptical, but when they got the whole picture, they got excited. So, more of this will be discussed actually by, in actual, how to implement this by Spencer from Launchit. They will provide us with the software and the platform such that we can put up the, let's say, a private placement memorandum. In this case, it's a 506C that allows the issuer to raise unlimited amounts of capital, okay, which is fantastic for us. And you can put this in a platform in such a manner that you can entertain accredited investors according to the regulations, existing regulations. And some people are not happy with additional requirements put up by the government, but we're happy with that. We will comply with that, and we will do that through third-party services. So, on the funding platform, which actually technically we should call a kind of a bulletin board, we can raise equity and loan and project financing. Now, the nice thing about this development is this. In the past, when you have a private placement memorandum, a PPM, it's in a printed matter. It's static. You read, you have pictures, fine, but if you put that on the internet, you can add videos, you can make your, let's say, financial projections interactive, so you can change assumptions and right away you see the results. Whereas you cannot do that in a traditional PPM material. So it's very nice. As a matter of fact, some of our video footages today will become part of our online PPM material. So, this is the last, and I have it very quick. I already mentioned the drivers. One of them is, of course, the source of raw material. Now, the United States and Canada is today experiencing a second oil revolution. One DuPont person who said it's a tsunami of oil coming in. Imagine that, a tsunami of oil. So we will take advantage of that. We don't even start to talk about natural gas. Most of you probably heard of natural gas. We're having so much of that. But this is something that's very good feedstock for us because it's the volume is going up, and the end product that the conventional refineries are producing out of that increasingly cheaper feedstock is gasoline, which is demand for it is decreasing. Okay, so if we use that to instead produce diesel, which is getting more expensive over time, then we have almost like a gold mine in there. So we're taking advantage of that. But the point that I'd like you to remember is that the United States is undergoing the second oil revolution. Now, not so briefly, others I'm going to talk a little bit more, but very quickly. DuPont has started to commercialize or put its name on a technology that was almost like nobody was, except me, watching a few years ago. As a matter of fact, I was in the Philippines when I saw that DuPont bought it, and I was so happy. Because even if this technology is fantastic, it was done by Process Dynamics, nobody will pay attention to it. Even today, DuPont will admit to you, and correct me if I'm wrong, that they're having difficulty getting immediate acceptance of this industry in the oil industry. Okay? And that's DuPont. But in my case, boy, when I saw that liquid phase processing, I mean, you know, well, he can tell you more about that, why it's fantastic, okay? But that's our business drivers. As I said, we would not have been able to do this without that technology and the credibility attached to it, which is DuPont. Now, the other one is also a very new solid-state catalyst. In the production of gasoline, we decided, I've been watching this for quite some time because this technology was developed by a number of companies. Originally ABB, Albemarle, and but then it was bought by CBNI, CBNI, right? Chicago. I found out it's not a U.S. company anymore. Anyway, this is they have been developing this for the last few years, 10 years. Okay, and I was actually in Finland, in Helsinki, when I heard about this from Neste Oil. That's the oil company of Finland, and I was there. And it's a fantastic concept. No acids. It's good. The production process is safe. It will not be a magnet to the terrorists. The problem is, again, the industry doesn't want it. In fact, when I asked Valero about it, they said, oh, we're going to fight that to teeth. But our philosophy is we will not adopt an established technology but not commercially available. So as a matter of fact, this is kind of an inside story, but when I first talked to DuPont, I wanted to use the sulfuric acid technology, which is their technology, because it is a lot less dangerous than your hydrochloric acid. Then, sometime March or April of this year, I found out that a Chinese company decided to use it. That means it's not commercially available, although it's established. And these companies are huge companies. CBNI is a multi-billion-dollar company. Okay. So I said, okay, now it's commercially available. I'm going to use it. But the model that we're going to be using is, instead of using it as an afterthought, I'd like to use it as the prime technology for a gasoline-centric dedicated refinery, where our feedstock is basically your LPG. Now here the LPG is liquefied petroleum, propane gas. It's liquefied petroleum gas. In the Philippines, it's a blend of propane and butane. But the thing is, we have plenty of that. So that can be a source of raw material for the production of ultra-clean gasoline using a technology called alkylation. Okay? More of that later on, but the point is we have that commercially available technology that we can use safely for the public and produce a gasoline that looks like this, doesn't stink like this. It's high octane, but no aromatics, no benzene. Again, if you Google the word benzene, it's very, very carcinogenic. So let's recap. I'm almost done. 1 minute. Well, we're ready to move ahead. I just would like to make sure that everybody's on the same page. Our directors, stockholders, our vendors, our clients, and most of us are here, moving towards our vision. Okay. Which is ultimately not just fuel refineries, but petrochemical, oleochemicals refineries. So, and we will do this with the support and in collaboration with our vendors like DuPont, Invincis, Zeton, Mars is not here. Again, we will play this kind of by ear, okay? And if you think that we're doing this, you just raise your hands. But we entertain questions now, and after that, we go to the second presenter, which is DuPont. But meanwhile, reactions from the panel. We entertain it and then questions.
I think it might be worth talking more about what you're planning on using for a feedstock.
Normally, isotherming is just part of, in the refinery, they call it an island, okay? So you have to have like your diesel, high sulfur diesel, and then you come up with a low sulfur diesel, okay? It will not be able to take in a feedstock like a crude oil, all right? Because crude oil has plenty of impurities, especially asphaltenes that will foul up your catalyst. So of course, just like any refinery, we have what you call a pre-treatment. So we'll get rid of the asphaltenes, and we'll get rid of the salts, water, etc., and what you call the light ends, like your propane, butane, pentane, hexane. Then we also get rid of the asphaltenes. Essentially, we will end up with your naphtha range, your kerosene range, your diesel, your light gas oil, and your heavy gas oil. And the whole thing we will desulfurize, but not just desulfurize, but intense desulfurization, that in the process you saturate your olefins, all your unsaturated hydrocarbons, you break the benzene rings, such that you come up with a product that looks like this and almost odorless. We have produced that already. Almost all of you are familiar with it. In fact, we exported that to Europe, okay, and it's being used there in buildings, inside buildings, okay, where traditionally they use ordinary diesel, even at 10 ppm or low. People get sick, but with this, they don't. So that's the kind of diesel we're talking about. But the feedstock, prior to the pre-treatment phase, is basically light crude oil. And it's perfect for us because the volume is going up, therefore the prices are going down. It starts with very low sulfur compared to the others, like 1,200 to 1,500 parts per million. And it's mostly saturated. So there's hardly any aromatics or olefins in there to start with. For us, it's an ideal feedstock. I might say it's almost a God-given feedstock for us. John?
Acid that there's Deo. Can you hear me okay? Sure. Second, can you touch a little bit more upon why that is happening right now, or why there seems to be so much more production just in the last 10 years, not just in North Dakota and Texas, but in other areas of the country as well?
Thanks for the question. Well, it actually starts with the fact that this country has been endowed with so much natural resources, and you start with the oil formations that are easy to extract, and then later on they realize the last maybe 2 or 3 decades, they already know the shale formation. These are rocks, sedimentary rocks. Underneath most of the continental United States, and there's plenty of hydrocarbon in there, but it's embedded in the rock. And it was only lately when the industry reached a certain, or developed 2 major technologies to a certain point of maturation, and that is your horizontal drilling, or I think I prefer to call it directional drilling. You can direct your drilling, and then use a technology that fractures the rock. And so when they fracture the rock using, that they reach through directional drilling, when they fracture that with water, okay, then they replace the water with sand to keep the crack open, in the process releasing the oil and gas. So those 2 technologies are the primary technologies that enable the efficient extraction of this oil embedded in the rocks that underlie most of the continental United States. So that started to happen just a few years back. Now, most people actually don't realize that we talk about Bakken, Marcellus, Eagle Ford, Niobrara in Colorado, but actually in California there's a lot more. But they don't talk about it because of environmental. California is very difficult to get permits, but there's plenty of oil in there, embedded in rocks. So if in the map, I mean, for my information, if Bakken is so much, California is like over here. That's why sometimes I go to the guys at the fair. He gave us a lot of oil, but then we quarrel about those things that, impact the world. But we have plenty of wealth underneath.
Well, I mean, what about the price of crude oil too? I mean, hasn't that impacted the, sort of the attractiveness of going after some of these difficult formations too?
So crude oil, of course, especially light crude oil, is determined by internationally Brent and WTI. And they are in the upper $100 per barrel range. Well, actually, when Bakken started, they're being sold at a discount because of they're kind of far from the main refining centers. Okay, so when we started, the price of Bakken went down to about $60 per barrel. Now it's going up a little bit because of now they can do the rail transportation. But the thing is, the volume is growing. It is growing, so the volume production. So naturally, all things being equal, your price will go down, and that's good for us. But you're right. We cannot use pure. We cannot start with a pure crude oil to feed into the main isotherming unit. We have to have pre-treatment of the crude oil such that it can be processed in an isotherming unit.
So just one comment or thing to flag, and we'll talk about it later, but in terms of the bulletin board and the financing platform, we should know that this is a relatively unsettled and new area of law.
Yes.
And so it's not said that, it certainly can be done, but there will be some work that has to be done in figuring out how to make it work and how to make it comply. And it's good. It's absolutely right that you're thinking about compliance because of course the SEC is going to do. But just to flag that it's not much like this is innovative technology in terms of creating energy. It's also innovative technology in terms of creating an investment setup. So there are a lot of different things that are sort of coalescing together to make this possible, but it is, we are on the cutting edge of it.
Right.
Yeah,
He's really right.
I'll follow up on that. It's interesting because when you say that, so much of what you're trying to do, BioSyn, is democratizing refinery processing to entry level. At launch, we basically say that we're democratizing access to finance and capitalization. And Brian, it's totally true that, we are in similar spaces, both in, the physical aspects of your business and also in the financing aspects. And so here at launch, we're talking with Brian Krauschak, we're working with other companies, one of the criminal crowd bouncer, and basically as the SEC kind of moves forward with actually saying kind of what this is going to look like on the ground, we're actively reacting to that as well. So there's kind of formation on both sides, but as you'll hear from Brian and I, it's all happening.
Right. Yeah, just very quickly, you will hear more about that later on, but the law is there. There's already the law. It just requires the implementing rules and regulations, which over time may be amended depending on how it plays out in the market. But the thing is, the framework is there already, and we will be the first to take advantage of that. And our commitment is we'll do this in strict compliance with whatever rules the regulators might put up there. Okay, but it's there.